And let me see, screen share. With, wow, so many tabs open. Share. Okay, how's that look to everybody? Can they see my screen?
Looks good on my end.
Awesome, cool. By the way, if the frame rate bugs you, the web camera is like 17 years old. I got it to communicate with my grandparents back when we're like, oh, we need to go and video call them because they won't know what we look like type thing. So frame rate's going to be awful. But let's take you back to 1977. Take you back to 1977. The Commodore PET came out in 1977. It was the world's first all-in-one personal computer. Sold for $795, which goes out to like $3,000 or $4,000 in our monies today. And yeah, you are seeing it right. That is a cassette tape as removable storage on the front of that beast, and it had a 1 megahertz processor. Any of you out there who actually know anything about computers knows that that is nothing. In 1977, the Pontiac Trans Am, this one being the Pontiac Firebird Trans Am, becomes iconic in the film Smokey and the Bandit, which was released May 27th, 1977, excuse me. The hit TV show MASH, which was just on TV, by the way, airs its 6th season, starring Alan Alda and many other recognizable characters. It would run for 11 seasons. This actually was taken during the 5th season. And as my garb would imply, in 1977, the first Star Wars film is released, becoming one of the highest grossing films of all time. Now, imagine you're a child of the 60s. You remember sitting on your mother's green, brown, whatever color carpet with the mismatched wood sofas, watching, hold on, get it to start. Watching this happen before your 10-year-old eyes on the TV that is also a record player, cassette tape player, 8-track player, and also radio. You know, you've got that wood paneling all around you that kind of echoes all the sounds, and you remember seeing humans land on a foreign body for the first time. And you knew right then and there in your 10-year-old mind that that's what you wanted to do. That's what you wanted to dedicate your life to, becoming an aerospace engineer or a rocket scientist, they'd call it, an astronomer. Science was what you wanted to dedicate yourself to, because look, they landed on the moon, and it took a lot of smart people to do that. You wanted to be the next Robert Goddard or Neil Armstrong or Buzz Aldrin, or probably not a Werner von Braun, but you wanted to be the next big scientist. You wanted to be able to land on Mars. It's getting to 1977, and you are a college-age kid. Now, you're looking at colleges. You're thinking, should I go to MIT or should I go to Stanford or maybe UCLA, UC Berkeley? You want to go to a science college, but the best way that you've really seen these planets, these outer planets in our solar system, is, slide next, there we go, do the thing, there you go, is through a telescope. And this is what you see Jupiter look like. And yeah, it's interesting, but it's 5 dots, one of which is absolutely massive. That's not very interesting to look at. What we've already learned from this, we've already learned from Galileo 400 years ago. This is Saturn. Wow. Oh, it's magnificent. This is just an oblong smudge, essentially. That's Uranus. You thought my video's picture quality was bad? This is awful. And that's Neptune. So, we didn't know much about this. What if I told you that in that year of 1977, the same year Star Wars and Smokey and the Bandit and the first all-in-one personal computer and MASH was on TV, was a mission that is still ongoing to this day, was launched from Cape Canaveral, 2 of them. Ladies and gentlemen, and everyone in between, I present to you the Voyagers from planet Earth, our first look at the outer solar system. And I'm being a little dramatic because, well, I can do that. But technically, Voyager wasn't the first to go to the outer solar system. Voyager 1 and 2 were follow-up missions to Pioneer 10 and 11, but Pioneer 10 and 11 only saw Jupiter and Saturn, if I'm not mistaken. They didn't do the in-depth research that we would see with Voyager, and they didn't even meet Uranus and Neptune. But nonetheless, they were probably the best look we had. So the mission profile. I am not a scientist. That's a disclaimer out here. I am a nerd and a historian. Those two things rarely go together, but this is one place that they do. So I will tell you what these things are called, but I won't be able to really tell you what they do. I've even tried to read the Wikipedia pages on some of this stuff, and wow, it is far beyond my pay grade. So first off, we've the Voyager, I believe this is Voyager 2's layout, or Voyager 1. They're pretty much identical with a few things changed. They had an imaging science system, which obviously takes pictures. Radio science system looked at things in the radio band, radio telescopes, essentially that, but in space. The infrared interferometer spectrometer does spectrographs on particulate and whatever it can get close to, and also was able to measure magnetic forces. In the next instrument, the ultraviolet spectrometer kind of did the same thing, but in the ultraviolet spectrum as opposed to the infrared spectrum. This next one I included in solely because A, I included all the instruments, and B, it sounds like it ought to be on like an 80s DeLorean. The triaxial flux gate magnometer. I'm not even going to touch what that does. Plasma spectrometer, low energy charged particle instrument, cosmic ray system, planetary radio astronomy investigation, a photopolarimeter system, and a plasma wave subsystem. All of these powered by, if you can see that little black cylinder underneath the probe, powered by that nuclear reactor. We'll talk about that nuclear reactor a little later. So in the beginning, God created, no, I'm sorry. In the beginning, Voyager 2 was launched before Voyager 1 because just like Yoda, NASA goes backwards sometimes. Voyager 2 was launched August 20th of 1977, and Voyager 1 was launched September 5 of 1977. And you're wondering, well, why? Why did they launch them then that way in that year? No, it's because our outer planets were arranged in a perfect way to allow for the probes to slingshot, meatbag. And you might be wondering, what do I mean by slingshot? Well, here is the layout of the missions and the solar systems. Hello, Caroline Kirby. Of our, thanks for donating $5 and listening to my Twitch stream. No, so the outer planets were arranged in such a way that each probe was going to be able to visit, at least Voyager 2 was going to be able to visit every planet without using extra energy on its own part to get there. Basically, once it gets to Jupiter, it goes around Jupiter, uses its gravity, and Jupiter essentially throws it at Saturn with minimal TCM thruster stuff going on the probes themselves. This happens once every 136 years. Happened in 1977, which means it'll happen in about 100 or so years, probably around 2100 is when this will happen next. We'll see if humanity's even around in 2100, but we must continue. On September 1st, or September 6th, Voyager 1 took this picture of the Earth and the, what is going on? Right, of the Earth and the Moon, which was just, this is just one of the best pictures in my opinion. It really shows that scale between the Earth and his throne, the Moon. Really like that, I really do. But we get to the meat and potatoes, the meat being Jupiter, the king. In February to April of 1979, Voyager 1 begins its flyby of the king. And it would be on station longer on Jupiter and Saturn than its counterpart, Voyager 2, at the cost of not being able to see Uranus or Neptune. So let's look at these pictures. This GIF here, and yes, a GIF, was taken on approach by the probe. You can even see, if you look towards where the great red spot is, you'll be able to see what looks like artifacts in the film, which are either artifacts in the film or it is actually planets going in front of the camera. So here we can see Io and Europa photobombing pristine Jupiter, Europa being on the right and Io on the left. We will learn far more about these moons later. This is taken February 13th. And that one textbook, you know how you always have those astronomy textbooks and they always have to like, here's Jupiter and here's its atmospheric composition and here all the like facts about it. Well, this is that picture they always use, and it was taken by Voyager 1 on February 27th. Hard to believe that a picture so good came out of, from a probe millions of miles away in the 70s. This was actually not just one picture, but it was a 3x3 mosaic with 6 extra frames filling in the missing data. Essentially, all the high resolution photography by Voyager is a composite. It's several, or in some cases, tens of photographs carefully matched together to create a very large picture. Kind of like how satellite photography of Earth works. You don't take one picture Earth and call it, that's good. No, you take lots of pictures, piece them together, and you get high resolution photography. Here's a detailed Great Red Spot taken March 1. Now you'll notice in these photos, we'll jump from mid-March or early March to April. And that's because on its closest approach to Jupiter, Voyager couldn't send things back because Jupiter's interference was far too great for NASA to actually get any usable data out of it. So there'll be a break in that. This is March 1. The next day, we get this very dramatic picture of Europa. And as you can see, it looks like fissures or cracks are in the surface of Europa. That is going to be important later. On March 4, we discovered something interesting. We all knew that Saturn had rings, but we didn't know that Jupiter had rings. And rings Jupiter does have. The rings are actually the light part of this photo, the stripes that go across the center of the photo. This is what is that called? A time-lapse photograph, which is why the stars look like corkscrews, because Voyager kind of rotates once every 78 seconds, kind of like in this really lazy, like, wow, wow, wow. That's why the stars are doing that. But the stripe in the middle is the ring itself, and we'll see a better picture, well, a slightly better picture, one with color from Voyager 2 of the same ring system. Oh, great, more Great Red Spot. Now, to give you perspective on how big this storm is, it's big, and I can tell you it's big. Like, look at the size of that thing. But take 2 Earths, put them next to each other, and that's across from left to right. That's how big this storm is. This storm is bigger than our planet twice over. We thought hurricanes on Earth were big, especially like Superstorm Sandy was massive. Superstorm Sandy can't hold a candle to the storm that's going on here. And this storm's been going for 400 years. This is a awful picture of Ganymede. Don't touch your TV set. Your picture's fine. The picture itself is bad. Taken March 4. We'll see better pictures of Ganymede later, because you can't really tell from this picture, but it's actually one of the more interesting of the Galilean moons, the 4 big boys. But Io, Io is interesting. Io is great. Io really taught something to NASA, because for the first time we had proof that there was volcanism outside of our own planet on a moon of all places. Here is a 563 meters to the pixel 4 photograph composite of the surface, and it's a hellish landscape. Let's be fair. Like, there's sulfur all along the surface. We believe that very toxic substances make up what comes out of these volcanoes. This isn't just lava. This isn't just superheated rock. This is acids and sulfur and brimstone. Literally, hellish. But here is one of them erupting. In the corner here, we can see the volcano known as Pele erupting on March 5th, 1979 or 78. I can't remember what year it is. And this isn't just a happy accident that we saw it. This isn't just Bob Ross painting a tree. This is very, very ongoing stuff. Callisto, promise you, is the least interesting of the Galilean moons. That's it. That's all I got. This one is Io, superimposed on Jupiter, March 9, and I promise you, this isn't Photoshop. I thought it was. I looked at it and like, well, this has to just be a composite to show the scale. No, that's an actual picture. No touching up by NASA, nothing. And it just blows my mind. Some of the space pictures that I see are just so clear that it's like, wow, did ILM do this for a movie? Who knows? You're now leaving Jupiter, though. See, April 6, March 9, April 6. Yeah, they couldn't take pictures because of the interference. You are now leaving Jupiter. You are on the fastest available route, April 13. So you thought you were happy with pictures of Jupiter? Well, there's more pictures of Jupiter. In 1979, a little later that year, so it was 1979, we have another Voyager in King Jupiter's court. Props if you got that joke. It passed by the King. It was flyby. Didn't take as many pictures of Jupiter itself, but we got pictures of the moons, and that's what we wanted because, as you know, Voyager 1's pictures of the moons were kind of not great. So here is Jupiter and its photobomber up top, Io again, on July 6th. Great red spot again in very dramatic color, July 7th. This is where we get to the good moon pictures. This is better Ganymede. I call this better Ganymede. The biggest of the Jovian moons. It has a very complex surface. As we can see, it's kind of similar to our own moon in the fact that there are darker and lighter spots. But those patterns are very different from how our moon is patterned. There's no craters in the mare on our moon, but there are here. They're much more defined on our moon. They're lava flows. I'm not quite sure exactly what the dark spots are. Anything Voyager 1 can do, Voyager 2 can do better. Hello, Nile. July 8th, again, boring. It really is. Like, it's cool to look at. It's a very pretty moon, very pleasing. It's nice, balanced photographically, but not much else there. Not Io, this is Europa. This is the cold one. Europa is very interesting. And I'm going to let you believe that solely because I told you and we're going to move on. No, I'm going to tell you why it's interesting. So those fissures across the surface that kind of look like if you've ever been ice skating on a fresh ice rink after they took the Zamboni and smoothed it out, it looks like ice skate cuts in it. That's exactly what they are, except they're like I think they're like a kilometer deep in some cases. These are cracks in an ice surface. What we theorize is that there's a very, very, very thick layer of ice on top of Europa. As it has no atmosphere to insulate it, it just froze over the course of thousands of years. But the theory is that underneath that ice is a liquid ocean that could be heated by volcanic vents, which, in case you don't know, warmth, liquid water equals life most of the time, at least in the one case that we know, 1 out of 1, undefeated, right? That there could be life here. There's a greater chance of life on Europa than there ever was on Mars. Well, ever was on Mars. Than there probably is on Mars. Mars has traced residue of water. Europa might have a whole ocean, the entire thing, an ocean. We see the same thing kind of on Ganymede. There are weird fissure-like structures on there we'll see. In fact, in this picture, it has that, when like water freezes when you walk to school in the ditch and you look at it and it's got those really cool crystalline patterns. That's exactly what's going on Ganymede. They don't think that there's a lot of liquid water on Ganymede, but hey, it kind of looks like it. And here is the 87 Bestamede mosaic of it. And yes, they missed a part of it because they're probably going by and like, take the pictures, oh, we forgot a whole section of it. Oh, well, we'll just say that aliens flew by or something. I don't know what NASA gave as the reason. But this was taken July 9th of 1979. And in case you wanted to see them on the dark side of Io, here it is. You have the volcanoes nicely lit up by a backlit sun. And we see not 1, not 2, but 3 separate eruptions. It's so common because Io is so close to Jupiter. It's essentially kneading, like bread. Jupiter's gravity is pulling and pushing and just working the core of Io, keeping it going. All that friction from all that gravitational distortion is keeping its core alive. Kind of like how Earth has, working tectonic features and, an alive core. The moons usually don't, but Io's was kept alive because of Jupiter's gravity. And I want to speak to you in a language that we can all understand. Here's Io in living color with 2 more eruptions and a third you can barely see happening on the dark side. Essentially the same picture, but one's in color. NASA liked Jupiter enough, they put a ring on it. Here's another picture of it. Jupiter itself is blocked out of this photograph because when taking pictures of something with high brightness and low brightness, and you want to see the low brightness in any sort of quality, you have to cut out the bright part. Otherwise, your camera is going to either get broken or just won't pick up that dark stuff. If you've ever seen pictures from the SOHO missions to the sun, there's a big disk in the middle so that you don't see the actual sun. All you see is the coronal mass ejections. We're going to see this again with Neptune towards the end because, spoiler alert, Neptune has rings also. Well, that's a Kronos, the dog, not Kronos, the planet. Let me fix this. There it is. Kronos, the planet. Well, not Kronos, it's Saturn, but what can I say? And NASA's a bunch of Romaboos. Between October and November of 1980, Voyager meets with Saturn, Voyager 1. It says Voyager 2, and I didn't fix that. Voyager 1 meets with Saturn, and wow, there's that one textbook picture again, because every single textbook picture of these planets came from one mission. This was taken before Voyager 1 got too close, because it would eventually get too close to take a single picture that was worth any amount of good pixels to take. And we can see here that Saturn has just slightly different cloud formations than Jupiter did. Jupiter had those very distinct bands of clouds, very colorful. You had whites and reds and oranges and all these different colors. Well, Saturn's pretty much just an orange ball with banding, I will say, but it's mostly just darker or lighter. It's not different colors. So NASA was sort of surprised to see that it formed different cloud formations. We'll also see storms later. Here is Rhea, the most boring moon we'll talk about tonight, I promise you. It's not a bird. It should have been a bird. That would have been more interesting, but here's Rhea. This is an interesting moon. This is Titan. If you've never heard of Titan, it's the only moon in our solar system that has any substantial atmosphere, a very thick atmosphere, similar to Venus's atmosphere. And this was taken November 11th. We'll see more detailed pictures of Titan later by Voyager 2, of course. But here's the rings of Saturn, the obviously most interesting feature of Saturn, the rings, the one you can actually see from Earth. And the rings, I believe, were no more than 30 kilometers deep or thick in some spots. And that would essentially be the same thing as, let's see, if the diameter of Saturn was this tankard that I have conveniently sitting over here, the rings would be no thicker than receipt paper going around it. That's the same proportions that you got. This is also a receipt folded over 3 times. So imagine if it was like this. That's about the same dimensions that you have. Take a CVS receipt, essentially that. And well, see, my people, the rebels, are going to blow this thing up. I had to make the joke. This is actually Mimas. I've made this joke like 4 times for different presentations, but it's perfect. I mean, it was what? Launched in 1977. They find a Death Star around Saturn. Come on. This is actually Mimas or Mimas. It's actually more surprising the fact that a crater that large was able to form on such a small moon and not break it apart. But yes, I will assure you Space Force will do a trench run on this someday in the near future. And again, we are on the fastest available route. We have to say goodbye to our friend Voyager 1. This isn't the last we'll see of Voyager 1, I promise you that. But for now, au revoir. Voyager 2 makes meet up with, guess who? Saturn again. But this is in 1981. And we discovered a few more interesting things. Here is just Saturn. If you'll notice towards the bottom right corner, you will see a weird ribbon-like cloud formation. It baffled scientists. And my theory, I believe what I read, was that they think it was the remnants of a storm system getting like torn apart, or clouds underneath the toppest layer. Because these clouds have depth. It's not just like, oh, like Earth, where there's a rocky base. These clouds go on. We don't even know what's at the bottom because we haven't been able to build probes deep enough. Galileo was crashed into Jupiter and only got so far before it was crushed by the immense pressure. We don't know what's at the center of these planets. There's a lot of clouds, though, so that could be a lower cloud formation or even above the main body of atmosphere. Now, rings to survive need shepherds. Shepherds are the boot that stamps down on all the dissident particles that don't want to be in the rings. F ring is the one between these two shepherds. That's that little narrow one that goes around in all the pictures. You can't even see it in this picture. But to maintain that ring, these two shepherd moons essentially gobble up every little particle that comes in their way that isn't in the rings. Keeps it nice and tidy. That's why these rings have been able to stick around for hundreds of years. These rings, by the way, won't stick around forever. Ring systems are not perfectly stable and will eventually disintegrate. So Saturn will become the least interesting planet in a few thousand years. Also, you can see the presentation reflected in my visor. Isn't that awesome? So, is the false color image of the rings. Each one of the colors is a different size and composition of particulate. As you can see, it kind of, blue stays in the center. You don't have much blue towards the outer except in that Cassini division. And it gets greener. You have that orange band that gets greener on the way out. No, I don't know what the colors are. NASA didn't tell me what the colors are. I got this image straight from NASA, and they didn't tell me what the colors were. But Saturn has spokes. Like any good wheel, Saturn's rings have spokes. These dark patterns that are in the rings aren't just like a light refraction that particular angle has. When the rings spin around, which they do, those move with it. Those are less dense areas of the rings. There's a GIF that I did not include on this presentation because it was very, very small and looked bad when blown up. But it essentially shows the spokes going and then coming around back. Iapetus was just not discovered, but first photographed on August 25th, and it's a very interesting two-tone moon. That's all I got. We're never going to talk about Iapetus again, so. But Titan, guess who's back? It's Titan, and it's very orange this time. This is as true to proper color as Voyager 2 got it, but it got an even cooler picture behind it 3 days later. The diffusion of light on this, as you can see on the far right side, the diffusion of light around the eclipsed part of the moon shows just how thick of an atmosphere it is. If this was just a rocky body like our moon, it would be a nice crisp line. The terminator line between day and night would be very crisp around the whole thing. This has a lot of diffusion, a lot of subsurface scattering in this atmosphere, which just goes to show how thick it would be. Another mission would be sent to Saturn it got on station in 2006, I believe, and it was the Cassini-Huygens mission. Huygens actually landed on Titan and sent back mass amounts of data, but that is out of the scope of our presentation because we're talking about Voyager. We ain't talking about Cassini-Huygens. Maybe next time. Tethys has a chasm. This is another moon of Saturn, showing some pretty good battle scars. And if you can't see it in this one, here's a higher resolution picture taken the same day. Across the left side of this moon, you can see a nice gash across the surface. I believe at its deepest point, it's about 1 kilometer. It shows the tumultuous history that a lot of these rocky moons had. Lots of things hit each other, and they can't necessarily reform themselves into a perfect sphere. This is another moon that might harbor life outside of Earth. Just like Europa has an ocean, we believe that Enceladus has something under its ice. As you can see, there's a cratered section and a not so cratered section that has a lot of the same fissures and cuts that Europa had. We don't know if there's any liquid underneath this. If there is, it's certainly not as deep or as big as Europa's, but again, there might be liquid water. And here is a study in orange. This is using its natural light, and it's the same picture, essentially. But one's using the natural light that is reflecting off of Saturn, the other one's cleaned up. It's like, hey, it's probably not orange, guys. So, and another picture, this time rotated, because you can't have enough pictures of Enceladus. And Voyager 2 makes its pass of the most boring planet in our presentation. Uranus itself has nothing interesting to show us, really, truly. The moons and the ring system is really where Uranus shines, even though Uranus is the only one not named directly after a Roman god. It's named after the Greek one. So here is a false color coffee ring that we discovered on the bottom of it. Perhaps Uranus himself left his coffee mug on the base of his own planet for far too long, but it's a storm. These false colors images show us things that we couldn't normally see. And these are storms that could be developing underneath the surface clouds since it's so blue and pristine. Here is, again, the comparison. These are the same photograph, one in true and one in false color. Here's a blue moon +1. We got 1986 U1, U3, and U4, which hints at the existence of a far more powerful U2, but I think that was shot down over Russia a long time ago. Here is the red-headed mermaid. This is Ariel, the moon Ariel, which shows lots of battle scars. It implies the fact that Ariel wasn't one moon forever, that a lot of different objects came together, just like its sister, Miranda, the Mishmash moon. And here's a higher resolution picture. There's evidence that several celestial bodies came together to form this moon. Here's the rings of Uranus taken in January. I didn't get an actual day on this one. A very faint moon system. One should also remember that Uranus is tilted 90 degrees on its axis. The Earth is tilted 23 and change degrees from the sun. Uranus is tilted a whole like 89 degrees. So everything's sideways. The rings are top to bottom instead of around and around. That's probably the best fact of Uranus. And we must depart this pale, pale blue dot. And you thought we were done with blue planets. Here's another one, but this one's actually a lot more blue and at least has surface features, right? And you thought that great spots only came in red. This one's in dark blue. The great dark spot is disappearing just like its counterpart on Jupiter, but it's disappearing at a much faster rate. It was a not as big of a storm, if I'm not mistaken. This is interesting as it shows that there are clouds over top of the main body of clouds, similar to how we see clouds over an ocean. This is like a jet stream. This is like the jet stream of Neptune. You can see a drop shadow on the right side of these clouds that show that it's above the surface of the main gaseous body, which they hadn't seen before on any of the other planets. Neptune has rings too. Here's that picture where they blacked out the middle section so that it didn't ruin the camera and also could expose the rings itself. And this is a pretty colorful moon too. I could actually hang a picture of this on my wall. This is Triton, very rainbowic. Rainbowic, that's not even a word. Rainbow-ish, there we go. One of my theories onto why this is, and it kind of is backed up by how the surface is done, is that when this was hot, the surface cooled down much faster than the rest of the moon, which led to essentially, when a nuclear bomb is dropped, glass is formed on the sand it's dropped on, especially when it's in Nevada within range of Las Vegas. You can actually see the glass left behind. I think that's kind of what happened here is the surface fused together and created these really nice natural prisms that reflect the light in so many ways. And here's Triton after closest approach, nothing but a crescent. And we must say goodbye, farewell, and amen to our outer solar system because Pluto didn't matter to Voyager. There was no way they could have even gone by Pluto because we didn't have enough data on Pluto at this time to know how to even send one by there. But this is the end. So I'll take, no, wait, this isn't the end, is it? This can't be the end. There's more to Voyager. We're in the 90s now, right? It's like the greatest generation. I'm kidding, that's a joke. But no, we're not done. On February 1st or February 14th of 1990, Voyager 1, before turning off its camera, took a family portrait at 6 million kilometers. I believe that's what it said, or billion. I can't remember if it was billion or million. As you can see, there are 6 letters on this mosaic of photographs. Each letter corresponds to a planet. Voyager took a picture of all the planets it could see at the edge of the solar system. We have Neptune, Uranus, Saturn, Jupiter, Earth, and Venus. Mercury was too close. Mars was in a position that they couldn't actually get a picture of it. And Pluto, they couldn't even find it. I think they even tried to find it and they couldn't. This was basically Carl Sagan made them take this picture. Carl Sagan was a big deal in the beginning and the end of Voyager. And he kind of made a stink. He's like, hey, if they're going to take last picture, it should be this. And then they shut the cameras off. So its ongoing mission is to discover new life. These are the voyages of the Starship Enterprise. No. While the cameras were turned off in the 90s, that doesn't mean it's over. there are 4 and 5 instruments still operational after these 40 years on board these probes, which are studying the edge of our solar system. That's what its new primary mission is to study what lies beyond the Oort cloud, the Kuiper belt. What's there? We've never been there before. So this is the only graph I show, I promise, and I apologize for anyone whose eyes adjusted to the dark presentation. But we can see in 2004, Voyager entered the termination shock of the heliosheath and exited that in 2012. Voyager 2 did the same, starting in 2007 and exiting afterwards, after this graph was created. The termination shock is the edge of the solar system. It's where the sun's influence, what the sun's spewing out, matches what it's running into in interstellar space. You know, when you run a sink and the water comes out of the faucet, hits the sink, and it runs out, and it starts filling the sink up, and that water starts rushing back into the sink. That part where the water pushing out equals the water coming back in is that termination shock, and it left it. Voyager is here now. Voyager is in interstellar space. By the way, that graph was of particle density because a lot of things are getting pushed together in that heliosheath. So what's next? Voyager's out of the solar system. Its instruments aren't working. In fact, there was a funny incident where someone left the oven on one of the Voyagers, and that is not as much of a joke as you think. There are heaters on board Voyager to make sure that instruments work when they're supposed to. Well, in 1994, in November, they sent a transmission out to Voyager, and it picked it up. It picked it up wrong and turned the heaters on for one of its instruments. And the heaters ran for a whole month before NASA realized that, hey, yo, we like turned the heaters on the ferromagnometer, and it's been at 130 centigrade for the past month. And I don't know if it ruined the instrument fully, but it wasn't supposed to be able to withstand those type of heats. But it's been through a lot, and its nuclear reactors are running out of power. But there is good news. One of the Voyagers was slowly getting out of alignment with Earth. That dish has to be pointed back at Earth for Earth to talk to it. And the dish was slowly going, wandering off, and we wouldn't be able to talk to it anymore. So for the first time since 1980, they tried to fire the TCM thrusters in 2019 or something like that. The TCM thrusters being the trajectory control modules. And lo and behold, they worked, and they're able to realign Voyager so that we could still see it. The projected date of termination is still, though, in the early to mid 2020s. I did Photoshop this tombstone. Rest in peace, Voyager, presumptive. I honestly, just on a side note, I really hope that when the Voyager missions finally give their life up for the pursuit of a scientific knowledge, that we build like one of those heroic equestrian statues of it outside of like the NASA headquarters or at a Kennedy Space Center. So you have like this majestic horse with a space probe riding the back of it, because that's honestly how we should honor this. That's the end, right? Can't be much more. Batteries are running out, nuclear reactors dying. It's the same joke. It's not over. It's never over. So overdue homework and a cosmic mixtape. I promise it'll make sense soon. On board both of the Voyager probes are golden records. This is the case of the golden record. At the bottom, we can see a binary or a rudimentary interpretation of a hydrogen atom. Hydrogen? Yes, I believe it's either hydrogen or helium. I can't remember. I think it's hydrogen. Hydrogen gas, actually. No, it's hydrogen gas. That's right. Showing without any symbols, without H's or anything, to show, hey, this is hydrogen. So the aliens can match it up. Whoever's going to find it, the extraterrestrials, can match it up with what they know hydrogen to be. The cool pattern next to it is actually the distances to the nearest 15 stars, so that they'd be able to figure out exactly where Earth is, at least the solar system would be, assuming that those stars remain their current position. The rest of it is just instructions on how to play the record inside of it. Yeah, we assigned homework to these aliens. We didn't give them a record player. We didn't even give them a needle. The record doesn't even run at a normal speed. It runs at 16 2/3 revolutions per minute. Contains 115 images, greetings in 55 current and historical languages, and a selection of human music. I like it. Of the human music on board is Bach, Beethoven. No Bach, excuse me. It's Beethoven, Mozart. There's Bach. Stravinsky, Chuck Berry. Yes, Chuck Berry got on board. Johnny B. Good, the one from Back to the Future. Interestingly enough, the Voyager committee didn't want to put it on there, and Carl Sagan said, hey, we need to put this song on there. And they're like, but it's teenager music. And he's like, yeah, but teenagers are going to be adults here soon. They even wanted to get the Beatles on it. The Beatles wanted to be on the record too. They wanted to put Here Comes the Sun. Do-do-do-do. But EMI, the recording studio, said no. So a recording studio stood between the Beatles literally becoming the first rock and roll to be introduced to a foreign alien civilization. So remember that when you think about how awful recording studios are when your YouTube video gets marked down for UMI copyright violation. So here's the actual record, and here's the record being put into the case. It's a double-sided record, and it contains, like I said, 115 images, of which these are a few of them. Woman eating grapes in the store. I certainly hope she paid for those. But what's more interesting is the fact that a bag of carrots is 77 cents a bag. Man, I'd kill for carrots that cheap. Here's Jupiter. This one was from the Pioneer missions. As you can see, not as great of image quality. It also shows the scale, hopefully to give the extraterrestrials the information that they need to understand what numbers are and that type of stuff. I promise you, this is an actual photo carried on board the Voyager spacecraft. This is supposed to show that humans use taste as a way to enjoy themselves. So we have a lady eating ice cream in a very normal, usual way. We see a guy eating what I can only assume is a sandwich that he took a bite out of both ends for no reason. And then Gary over here on the right busted in with a pitcher of water and just like, ooh, I need my water. It's honestly the weirdest thing I've seen. I saw this on the Wikipedia page for it, and I'm like, I have to include it. That is such a crap post. Here is the Arecibo telescope, again showing scale to have aliens hopefully understand what things are. And I like this picture personally. If you turn your head upside down, or your computer, or your phone, you'll see that the Red Sea would be at the bottom, our top. The dark line across it is the Nile Delta, and this is Egypt. The numbers themselves refer to the composition of our atmosphere. Nitrogen gas, 78 parts per 100, O2 at 21 parts per 100, water, H2O, at 1 part per 100, and the now unfortunately incorrect CO2 at 3 parts per 10,000. They're going to get here and they're not going to find Earth because it's too much CO2. And they're like, well, it doesn't match the pictures they sent. But I will bring you to its most stunning image, in my opinion, something I want to get framed and put on my wall on a nice big poster. And this is the pale blue dot circled up there. This is our home. And I'm not going to read the Carl Sagan thing. I did it during the dry run, but I'm not going to read it tonight because it's very cliched and I'm sure you've all heard it. But to boil it down, what Carl Sagan said about this picture, this last picture that Voyager 2 sent, is that, or Voyager 1 sent, is that everything you've ever known, everything you've ever loved, anyone you've ever known, everybody that you know and love and care about is on that pale blue dot. Millions of people were killed and slaughtered for control of small parts of that dot. Endless life lost for no reason. People starve, people make it big time on this pale blue dot. It really brings us into perspective on how little we actually matter on the cosmic scale. Take that as not as something depressing like nothing matters. What matters? 1,000 years from now, we might not even be here. Take it as, hey, nothing matters. That mistake you made 4 years ago doesn't matter. Humanity doesn't matter on the cosmic level. Aliens aren't certainly going to miss us if we disappear. And take that as, do what you want. Do what makes you happy. Because in the end, no one's going to judge you but yourself and the people around you, but they don't matter either. Is that the end? Is it? Huh? Yeah, it's the end. I'm not going to do the joke 3 times. So I'll take questions if anybody wants to offer them, and I'm going to take this thing off because I can't actually hear anybody through this. Okay, I don't know how to do questions, field questions through this. Actually, oh, gallery mode.
They're in your chat.
In the oh, they're in the chat. Okay. How do I get the chat? Oh, here it is. Chat. There we go. Oh, thank you. Thank you very much. Anybody have any questions? Remember, I'm not a scientist. I can't give perfect what is that called? I can't give the scientific reading on a lot of this stuff. I'm a historian first, and that's why I chose this topic, is because it was 40 years ago, and this mission's still ongoing and will be for the next, hopefully, 5 to 6 years. But if anybody does have a question, I would love to answer it to the best of my ability. No? Nobody? Awesome. I'm not really good at answering questions all the time, so I appreciate it. Okay.
I would like to say thank you,
Thank you.
because that was wonderful.
Aw, you're too kind.
And I'm very glad to have you back presenting. You did a wonderful presentation.
Thank you very much. I was happy to be able to present on something I truly care about.
While you're thinking about your questions, if you will put in the chat where you're joining us from, it's something we do at each meeting, so it gives us an idea of where our audience. And I'm just going to put it out there. Our furthest participant was in Indonesia, so we're trying to beat Indonesia. So, yes, we got Seattle and got Ellensburg.
I'm in Port Orchard, if that matters, but that's not too far away.
Ooh.
The scenic Port Orchard. Ooh, Chelan. Leonardo! That's all I can imagine. It's all caps, so it's got to be screamed, right? Felipe from
Lake
Texas, I
Chelan, he
appreciate
corrects
that.
it. Leo was a Teach STEM student. He graduated last year, and he's teaching up in Lake Chelan. And maybe he'll invite his class one time to come and sit in with
Ooh,
us.
that'd be awesome.
We've got New Mexico. So
Mexico.
far, that's the furthest.
Mariano. You can't be that terrible. I can't imagine that's too terrible. I'm full of these awful jokes. I watch too much MASH.
Hi, Leo. How are you doing?
It is terrible, not terrible. Exactly.
Oh, terrible. Sorry.
Yeah.
Mariano
Yeah,
terrible.
most people call it terrible, but it's terrible. Anyway.
Thank you for the
Texas
correction.
has New Mexico beat. So
I don't think we're close
trying
to
to beat
Indonesia.
Texas now. Yeah, I don't think we're not close to Indonesia.
Pretty close to be on the other side of the world.
We can get like a South Africa. I think that would beat it.
Actually, I'm working on trying to gain a continent at each time we do one of these. I got to work for something. I belong to a group that is international, and that's how we got the last one. So I just keep plugging away, keep sending them out. We're gonna hit. We'll hit.
I could invite my grandfather next time in Israel.
There you go.
No, it's
There you go.
6 a.m. for them right now.
Wake up with a so-so presentation.
Our next astronomy event will be the last of this year. Actually, it will be on a Saturday, and that is December 5 at 12 p.m. Pacific. That will be a virtual planetarium event, so more close to a dome show like you're accustomed to seeing. Not sure who our presenter is going to be or what our topic will be, but I will send out the announcement to everyone once we get that going. We have an event coming up to sponsor for our Society of Physics students this weekend. We're doing a pumpkin drop, and my students are nodding their head. I need them to not only nod their heads, but sign up to volunteer. So we have pumpkins that will be dropped from our building. We also have the trash cano that's going to be going off on the other side of the building. So think volcanic eruptions going on one side and pumpkin drops on the other. Leo's asking for his mask to get here. Oh, thank you, Leo. That's a good plug for something you can do to support the club. I'll drop the link to register If you'd like to purchase a mask, they're $17. All the proceeds go for our student club. I believe they're due to ship out on Friday, Leo, if I'm not mistaken, because they're shipping out right before the event. And I'm grabbing the link for it right now. Christine, do you want to chat while I do that? Or Hunter, do you have any other things to present? Because it was a lovely presentation.
Oh, thank you. I would just say that I am very proud to have presented here. I honestly, Astronomy Club is like the major thing I miss from going to school. It was the one thing that kept me going through senior thesis and student teaching, because I'm not going to be a teacher anymore. So I might as well use the things I learned in teachery school here for some good. But thank you for having me. That's mostly what it is. I enjoy making these presentations, even if they are a little last minute sometimes. I finished actually putting the final touches on it this morning. Oh, I love, thank you. The side jokes are honestly one thing Enceladus, I love Enceladus too. And I like the jokes. In case you want to know where my humor comes from, it's 3/4 Tumblr and 1/4 MASH, Alan Alda. So I wouldn't say, actually, it's more like the other way. 3/4 Alan Alda and 1/4 Tumblr, because I only see the distilled Tumblr quotes on Reddit every so often. So yeah, that's my humor.
For Astronomy Club, next quarter we will be meeting earlier. So anybody who's accustomed to that 8 p.m. start time for astronomy, please get unaccustomed. We will be meeting at 5 p.m. via Zoom.
Gross. No, it's not too bad, I promise.
For those of you that are looking in the chat, I apologize for that very ugly link that I first sent out. Our university does something called safe links whenever we're attaching a link to an outside party, and it's just horribly ugly. So if you look at the one right underneath it that says mask link, that's a much prettier but still kind of long link. And if you can support the club, that would be awesome. The Astronomy Club, hopefully in the spring, we will be able to do some virtual observing with our research telescope also. So we're trying to do things that will allow people to get to see our night sky in addition to the presentations that the students do.
Thank you, Ryan, for putting our website into the chat. I really should save that link somewhere. I have not done that yet.
All right. With that said, see you guys. See everybody. Thank you for the
Take
show.
care. Thank you for showing up. Thank you for listening.
Yeah, no problem. See ya.
Does anybody have any other questions? Deanna, Dr. Falsher, anything to add?
I'll just say that I really enjoyed your presentation, Hunter. Thank you.
Thank you. Too kind. Here, I'm gonna mute myself just in case.
We actually have somebody lurking in here that's further than Texas. And I only know that because she's been to several of our presentations beforehand. And I believe Alabama. Mary, is that where you're from? I've scared her away. Oh, there she is.
Am I from where? I'm from Mississippi,
Mississippi, okay.
where the Easter tornadoes hit really bad.
Oh, sorry to hear that.
It's okay. We survived. We survived.
Thank you for joining us, as it's very late where you are also, so appreciate your support for the club.
And thank you. You're welcome.
I'd like to shout out, I think my dad should be in here somewhere. He was earlier. My dad was in this somewhere, but I think he left already. I think he's watching television, actually.
I am very glad to have all of you having joined us tonight. It has been wonderful. This has probably been one of our larger turnouts, just from looking at everything. And I think that's a great way to end the quarter. And the year. This is our last Astronomy Club event for the year.
May the next year be far better to us than this one.
We survived 2020, you guys.
Don't jinx it.
Don't celebrate it prematurely. We still got a whole month to go.
I mean, as a club.
I mean, yes, but we still got a month to go. We haven't even got the final boss yet.
Oh, God, no.
If
We're
the
gonna
final
see-
boss is officers meetings, I think the club will be fine.
I think it'll be fine, but you never know. Mimus might show up in orbit around Earth and blow it up.
Sorry for the shaking camera. My laptop is in my lap.
As it should be.
I think if I can make it through Hanukkah this year, I'll be fine. But that's a really, really tough statement.
I think everyone is in the same boat as you. Everybody is surviving one day at a time, and sometimes 1 hour and 1 minute at a time.
Yes.
But we're here, and holler if you need connection. Ooh, somebody is just joining us.
Who could it be? No?
Hunter, you have to do your entire presentation in reverse for them.
Let's see if I can get it back up. Share screen. Okay, so we're gonna start at the end because as all good presentations go backwards. So this isn't the end. I promise it's not the end. It's not the end. So we're gonna go backwards. Here's Earth. We're gonna get closer to Earth. So we're gonna get real close to Earth here. And we're getting there. We're at Uranus. We're at Saturn. We're getting closer. And Jupiter.
Was that my dog? Did you actually put my dog in the presentation?
Dog in there. How did you miss the dog?
I was in the bathroom for part of it.
Yeah, there.
That's my dog.
Emily's dog, Kronos.
I love him. He just turned 4.
It's quite the cute pupper. And in case we want to go through all the references real quick, we got a little bit of time. So His Throne, reference to Local 58, a horror ARG thing that's on YouTube. Definitely recommend the watch. It's got some really good content. Encounter with the King, also Elvis. Let's see. Oh, great, more Great Red Spot. If you ever watch Sorrow TV, that's one of the jokes for Facebook memes. Oh, great, more asbestos. Also, you're on the fastest available route. Also, creepy 58 reference. This is obviously Lord of the Rings, except he's complaining about not Jupiter, but lembas bread. But same thing, really. A Voyager in King Jupiter's court is a reference to a Connecticut Yankee in King Arthur's court. Time travel story before time travel was a big deal. Anything Voyager 1 can do, Voyager 2 can do better. Obviously, anything you can do, I can do better. The Best-a-Mead, if you've ever seen any one of CGP Gray's videos on YouTube, he always does the best of something in a bunch of his videos. This is the Best-a-Mead. I'll see you on the dark side of Io is I'll see you on the dark side of the moon. You know, come on, I gotta do it. In Living Color, I actually quoted a little bit of In Living Color from Cult of Personality song. I hope you've heard it. It's really good. NASA liked it, put a ring on it. I've never actually heard this song. I don't even know the name of this song. I looked up the lyrics for it just to get the joke right, and I still haven't heard the song. Kronos, obviously. Appearance of the Titan isn't actually, I think it's like Entrance of the Gladiators type thing. Star Wars. Shepherds of the Ephraim, that's not a Titan. Pint-sized Ganymede is actually a reference to the pint-sized slasher from Fallout 3, of all things. Blue Moon plus one. There's a Frank Sinatra song called Blue Moon, and we just had a blue moon in October. 2 full moons in a single month, and this is a blue moon plus one because it's physically impossible to have 3 full moons in a month unless the months are 68 days long, which there was one in ancient Roman times, but that's for later. Little Mermaid, obviously. Departure of Uranus is a horrible reference to a musical cue out of Star Wars Episode 5, The Empire Strikes Back, which is the departure from Cloud City. And look, more blue planet, same reference as Lord of the Rings. Goodbye, Farewell, and Amen is the final episode of MASH, which will be shown actually tomorrow on TV if you're interested. Family Portrait. Yeah. Yeah, I don't think there's any other references. Oh, right, Cosmic Mixtape. I forgot to actually say that joke. The whole thing is, imagine you're living in Japan and you find this deep sea rover or this deep sea submersible that was launched from the United States, and it washes up on shore, and you're excited to open it up, and you see that there's a CD in there, and you're really excited, like, what could be on the CD? What scientific data has the world not seen? You rush home and you smack it in your computer, and you see that it's someone's really bad mixtape with a bunch of family pictures on it. It's essentially what Voyager's golden record is. The crap post to end all crap posts. I honestly love this picture so much. And yeah, that's all the references. And I'll stop sharing now. Anyways, I will give my microphone up to Madam Christine.
To me, it would appear that we are done for the evening, unless anybody else has anything to add. And with that silence, I would like to bid you all a good evening and a happy holidays, and hope to see you again in January. And that is, I bet we'll be meeting for the first time of the quarter about 2 months from now. Let's see. We start on the 6th, Deanna? 5th? That's right, we start on Tuesday in winter quarter. That's the strange thing for me. So we will be meeting for the first time in 2 months and 1 day for winter quarter at 5 p.m. Yes, emails will be sent out.
Christine,
Yes.
the 12th is the second Tuesday of the month. Are you going to try and do a star party that close to starting again?
Let me email Martin, and I will get back to you from there, because he expressed interest in doing a star party. And if I had looked at my calendar before the meeting yesterday, I would have done the smart and asked if anybody was interested.
Is that our baby?
Yes, that was our baby doing the cough cough. I don't think she's awake. She's got a stuffy nose. And so she does the cough cough. So I will email Martin and get back to you, Deanna.
Okay. And I have pumpkins to paint because pumpkin drop. So I'm gone. Everybody, see everybody that's not a CW student. I'll see you in a couple months. For my students, be very good, stay safe. Make sure you get your test done before you head home. Make sure you be safe while you're at home, and I will see you in January. Take care, everybody.
See you in January. And I'm going to remain here as everyone files out, just to make sure. Hello. If anybody in astronomy is interested in just hanging out like we pretty much always do, send me an email or text me, and I will email everyone a link for a Zoom so that I can get rid of this one.
You could put it in the Space Force thing.
I could.